Everyone, and welcome back to Lyfey Technologies YouTube channel. I hope you're doing well, and thank you so much for watching this session. So this is another episode of our Huawei Lab Simulation series, and in this session we are focusing on how to implement segment routing MPLS with best effort tunneling on Huawei routing devices. So we know that segment routing, it's a new technology, and many service providers are either planning to evolve their network or to change their network from the legacy MPLS to segment routing. So many of you have been requesting for this session, and I've managed now to create this session for you guys so that you can understand how to implement segment routing on Huawei routing devices. Later, we'll be having another session on how to implement segment routing on Juniper, and then we'll also have another session on how to implement segment routing on Nokia routing devices. So please stay tuned in for more upcoming sessions. So we know that segment routing, again, I've mentioned that this is a new technology. And whenever there is a new technology, many of us as network engineers will struggle to understand this new technology because first, it's not deployed in our network, and many times even you don't find an environment where you can practice this new technology. So as a new technology, we still have to understand it because remember, it has many benefits that is bringing to your network. So you still need to evolve your network to segment routing and do away with the legacy routing options that we used to have. So this is a new method for routing packets in IP and MPLS aimed at improving traffic engineering and also improving on network scalability. So we are now moving away from the complex signaling protocols that we normally have in the network. These protocols like RSVP, LDP, we will not be deploying these protocols anymore. So imagine when you have to deploy MPLS L3 VPN, you will have IGP. On top of the IGP, you still have to configure protocols like RSVP, LDP for the signaling. And then you can now go ahead and implement the services on top of the infrastructure. So you realize that you are configuring so many protocols, and these protocols, they all have requirements or overheads on the network. So we are doing away with the legacy complex signaling protocols like RSVP and LDP. So this one, it will help to improve on traffic engineering and also improve on the scalability of the networks. So when we talk about segment routing, you also need to understand some basic principles. You need to understand some basic terminologies of segment routing. Of course, this session is more on lab simulation, but again, maybe later we can have a separate session on theory so that we help you to understand the theory. But some of the key concepts that you need to understand, we have segment. So when you talk about a segment, that's like an instruction that will tell the packet how to move through the network. Remember, with segment routing, the ingress router will put all the information, all the instructions on the packet so that this packet is forwarded throughout the network based on that source information that was added by the egress router, the ingress, the one at the edge where the packet is entering the MPLS backbone network. So you will be having different types of segments. You can have node segment, you can have link segment, you can have the prefix segment. So you need to understand all these terminologies. So when we talk about the segment list, so when you have segments, you can add them or you can stack them together to form what we call a segment list. And that segment list will define the path that a packet should take from source to destination. So when the router receives that packet, it will check the top segment. That is what tells the router what it should do next. So we have a stack of segments, and these stacked segments will be guiding the flow of the packet from the source to the destination. So for the control plane and data plane, when you have segment routing in the network, the control plane will be using the existing protocols like OSPF, SIS, and these protocols will be used to distribute segment IDs in the network. So you don't need RSVP, you don't need LDP anymore. And then in the data plane, remember we are talking about the MPLS label stack. So you can either have SR-MPLS segment routing based on MPLS, or you can have what we call SRv6, so based on IPv6. So you will not need MPLS if you are to deploy SRv6 in the network. So some of the benefits, of course, I've mentioned that we have simplified traffic engineering. We don't need RSVPT, we don't need LDP anymore, because this one will be done, the control functionalities will be done through the IGP. So we are extending the IGP protocols so that they can be able to handle that functionality. We have fast reroute, which is inbuilt within segment routing. And then you can have either MPLS or IPv6. So you can migrate your network from the legacy IP to SR-MPLS, and then you can migrate to SRv6. So it's also flexible. It will enable you to have things like network slicing, service chaining, and also the 5G backhaul transport. So those are just a quick overview of some of the basic principles of segment routing, or the source routing. Sometimes we refer to it as source routing, because all the information required to forward the packet is placed on the packet or is added onto the packet at the source when it enters the MPLS backbone. So that's just a quick overview of segment routing, and now we can go to the implementation. But before we move to the implementation, just a kind reminder that if you are watching this video and you are yet to subscribe to our channel, kindly support this channel by subscribing to it. You can also be a member of this channel. You can join our community, and we'll be glad to have you on board. So this is the topology that we are using, just a normal L3 VPN topology that we've been using for different implementations. You can see that we have the MPLS backbone. So in the MPLS backbone, we have PE01, P01, and PE02. And then we have different CE. So we have C1 and C2. This one, they will be in the same VPN instance. So we'll be calling them VRFA. So they need to communicate. And then we have C3 and C4, which will belong to VRFB. So they also need to communicate through our MPLS backbone network that is running segment routing. So of course, when you are implementing segment routing, you still need to do the basic IGP configuration. You still need to do the BGP configuration. You need to also implement the VPN configuration on this router. And again, one special configuration that we'll be adding is extending the IGP protocols so that they can support segment routing. And then we need to activate segment routing on these routing devices. So those are the configuration steps that we'll be doing on these routers. And once we finish the configuration, we'll go ahead and test that we have connectivity or communication between the CEs within the same VRFs. So the first step, this is the topology, and you can see this is the topology in ENSP. So we are logged into these routers, and we'll be doing the configuration step by step so that you are able to understand how to implement segment routing and the prerequisites before you configure segment routing on Huawei routing devices. So the first step, we need to do basic configuration. So we need to configure basic parameters on devices in MPLS. This is a step that we normally do on all our implementations. So you need to configure the sysname, you need to configure the interface IP addresses, both for physical and the logical. So the physical will be the one back-to-back connections, and then we have the logical, the loopback IP that we'll be using for other functionalities like establishing the BGP session. We'll be using this loopback interface. So these are the configuration on P1, very straightforward. Configure the sysname, configure IP address on the interfaces, and that is it for the basic parameters. So I log into P1, and then I will paste the configurations. Once I've pasted the configuration, I need to commit. On PE2 is the same. On This is P01. So on P01, remember we have connection to P1 and P2. So we need to do these configurations on both interfaces and also configure the loopback IP. So I'll copy these configurations, apply on P01. And then we can do the configuration on P02. So P02 will be having the back-to-back connection to P01 and also the loopback IP configurations. So these are the configs that we need. I'll go to P2, do the configurations. Once we've completed the basic configurations, we'll move to the next step. And the next step, we need to configure IGP. I've mentioned that even if you are configuring segment routing, you still need IGP connectivity in your MPLS backbone. So that's why we are selecting to use IGP, which is SIS in this network. So we've already discussed multiple sessions where you configure ISIS. So you see that we are configuring ISIS 10, we configure IS level, which is set to level 2, cost style. So when you are implementing segment routing, you always have to set the cost style to wide. You cannot use the narrow, and this one will be demonstrating if you are to change to narrow, will our peering sessions come up? Will we be able to communicate through the MPLS backbone? So we'll be verifying this in our next sessions. And then you need to configure the network entity. So you can see that for the network entity, we are generating it from loopback 0. The area is 0010. So this is the system ID, and the system ID we generated from loopback 0. The selector remains 00. And then we configure IS name for ease of identification of this peering session. And then we activate ISIS on the interfaces. So for the network entity, remember it has to be unique on the different routers. All the other things should also be configured correctly. So I'll configure ISIS on P1, and then we can verify that just in this. So on P1, I'll do that, and then I'll move to the next, which is P01. So on P01, we need to configure ISIS 10 and activate it on the interfaces, same way we've done for P01. And then remember, this requires a commit statement, so you have to commit. And then for P02, I'll do the same. So once we've configured ISIS, we can verify the ISIS adjacent this, display ISIS peer. You see that we have an adjacent towards, let me expand this slightly so that you can see the output. So you see that we have an ISIS adjacent towards P01. If I display IP routing table, you expect that we have ISIS routes coming in, which is okay. On P01, I'll display ISIS peer. You see that we have to adjacent these. So this is the good thing about configuring the sysname, the IS name. So you can see that it clearly tells us that we have a peering session towards P01 and P02. So I can display IP routing table again. Protocol ISIS, you expect that you are having ISIS route. On P02, we'll do the same, display ISIS peer. Display IP routing table, you expect to be getting the routes from the other side. So from P02, the most important thing is that we need to ping the loopbacks of the other routers. So we ping 1.1.1.1, see that we are able to ping, and then we can also ping .2, which is the loopback of P01, our provider router. So you see that we have connectivity. So that is the aim of having IGP. We need to ensure that we have connectivity between the different nodes in our MPLS backbone. And remember, this IGP will also be used to distribute labels when we have segment routing. So the next step, we need to configure MPLS. So I'll configure MPLS, and when you are configuring MPLS, you need to start by configuring the MPLS LSR ID. And this is where we also use the loopback IP. So you can see that we are using 1.1.1.1 for P01. P01 uses .2, which is the loopback IP of P01, and then P02 will use this 1.1.1.3. So I'll go ahead and activate MPLS. So once you have configured the LSR ID, you can now go ahead and configure MPLS globally. So you enable MPLS protocol on the router. So I'll start with P1. Then I'll go ahead to configure P1, P01. And then I need to configure P02. So we've activated MPLS on all the routers. We move to the next step. So for the next step, we need to configure segment routing on the backbone network. So this is where we are starting to implement segment routing. So when you are configuring segment routing, there are some few things that you need to do. The first thing is you need to activate segment routing on the router. So that's why you can see that we have segment routing. And then for this, we also need any tunnels to prefer segment routing. So we have segment routing. We configure services to prefer the segment routing tunnels that will be established on the router. And then under ISIS protocol, again, you need to configure the course style wide. Once you've configured the course style wide, you have segment routing. It's either MPLS or you are using IPv6, depending on your implementation. Remember, in this case, we are doing MPLS. So we are doing SR-MPLS. So that's why we are specifying MPLS. And then we are configuring the segment routing global block on all these routers. So when you are configuring the global block, you need to ensure that sometimes, of course, many will recommend that you need to have the same range on all the routers, or you can have different range on different routers, but it's always a good practice to have the same range. So this is just a range of MPLS labels. In short, we call it SRGB, segment routing global block. It's just a range of MPLS labels that a router will reserve to represent the global segment IDs. And these labels should be consistent across the network so that all routers should be able to interpret them the same way. So remember, this is just a range of MPLS labels. And again, you can go through the details and understand how it's used on the routers. So once you've configured the sRGB, and this one you must configure it. So you must enable segment routing on the global, and then you need to configure these parameters under the IGP protocol. Another thing that you need to configure is the prefix seed. So this prefix seed should be unique on all the routers. So you can see that on P01, we've configured a prefix seed index of 100. Remember, it's used when you are assigning the labels, so it should be unique. 100 on P01, we've configured a prefix seed of 101. On P02, we've configured a prefix seed of 102. So you need to ensure that this prefix seed is unique on all the routers, and because it will be used when you are assigning labels on the routers. So we do this and then we do the commit. So these are the configurations on P01, P02, we do the same. Again, you need to change the prefix seed index. On P02, you also need to do the same. All the other configurations remain the same. So I'll copy this. Then once we've done the configuration, we can verify that we have SR sessions up on the routers. So this is for P01. And then we need for P02. Once we've done the implementation, we can run these commands to verify our segment routing on the router. So display segment routing prefix MPLS forwarding, and you expect that you should be having sessions on the routers. So when you check these, let me run the command, you see that we have these sessions and they are set to the state is active, which means they are up. And you see that when it's I and T, it's ingress and transit. So ingress meaning that traffic coming in from the source. You remember, these PEs are connected to some customer edge devices. So that's why it's ingress. And again, if there is some traffic that is just passing through to the other destination, then it will be transit. So that's why here you can see that it's ingress and transit. E means, you can see that E, it's egress. So traffic destined towards this IP will be assigned this label. So you see the labels. We've configured a label space of 160,000. And that 160,000, you saw that on this router, we've configured a prefix seed of 100. So you see that this router has assigned itself 160, 100. On router 2, which is P01, you see that it has 160, 101. And then on router 3, you see that we have 160, 102. 102 is the prefix seed on our provider edge router 2. 101 is the prefix seed on the provider router, which is P01. So this one indicates that we are okay. Again, you can use multiple commands. You can check that just in the forwarding. You can check also a given prefix. So you see that this prefix seed, it's 102. This is coming from P02. The protocol, we are receiving it through SIS. Remember, we are using IGP to distribute these labels. The process ID is process 10, and you see many other details about this prefix seed. So you see the interfaces, you see the MTU, you see the label, the incoming label, and the out label. So for example, if you are sending to this router, then the out label should be 160, 102. On this router, you see that P01 is connected to P02. So that's why you are using the label number 3. And again, maybe if you've done MPLS, what does label number 3 mean? Maybe you can tell us in the comment section. Because these two routers are connected. So why are we sending a label number 3? You check on the other device. I'll run this command on P01. You see that we are sending label number 3 to both devices because we are connected. So if they have any traffic that is destined to us, they will use label number 3 again. Tell us in the comment section why this router is assigning label number 3 towards P01 and P02. On P02 again, you see that, let me copy the command again. I think I pasted it wrong. So you see that on this router, for the remote router 1.1.1, we are using this as the outer label, and you see that the label is 160, 100. 100 is the prefix seed ID of P01. For P01, we are using label number 3. Again, remember to tell us in the comment section why these connected routers are sending the out label number 3 instead of having a number like 160, 103. Why? If you've done MPLS, you definitely understand the reason. So please tell us in the comment section why we are having label number 3. What does it mean? What does it do? So we've confirmed that our segment routing is okay. Now we need to move to the next step. Step 5, we need to configure MP-BGP peering relationship. Remember, we are using VPN route, so we need to activate VPN before peering between the routers so that they should be able to exchange VPN routes between themselves. So we are doing BGP VPN before peering between PE01 and PE02. So I log into PE01 and paste, and then PE02, I'll do the same. Then we can verify the BGP session. So if I display BGP VPN v4 all peer, it will be idle for some time. So we wait for it to come up. It takes around some few seconds. So you can see that the session is now up. So we have BGP peering session established between the PE routers. These routers should be able to exchange VPN v4 routes. Once we configure the VPN instances and establish peerings with the customers. So the next step, we need to configure VPN instances. So for the VPN instances, remember our CEs will be separated into different VRFs, the virtual routing and forwarding. So you can see that we are creating two VRFs. We have VRF-A and VRF-B. So VRF-A will have C1 and C2. VRF-B will have C3 and C4. And once we've completed the implementation, we need to ensure that these C1 should be able to communicate with C2, C3 should be able to communicate with C4. So when you are implementing the VRFs, you need to first configure the route distinguisher. Remember, route distinguisher plays a very important role in the L3 VPN networks. And again, once you've implemented the VPN, the route distinguisher, you also need to implement the VPN targets or the route targets, which will be controlling how routes are exchanged between these PEs. So they will be checking, is this matching my import policy before they install the routes in their routing table. So when you are configuring the route targets on the different routers and you have customers in the same VRF, ensure that you use the same VPN targets. For the route distinguisher, we are using what we call the type 1 route distinguisher. So you can see that we are using the loopback IP and then colon random number. So that's how we'll be configuring the route distinguishers. So you see that here it's 1.1.1.1 colon 1. This one will be 1.1.1.1 colon 2. And then we need to bind these VRFs to the customer facing interfaces. This is for VRF-A and VRF-B. And then once we've done this, we need to configure the IP addresses facing the customers. So I'll start by configuring PE1. Once I've completed P1, I'll do P2. So we do similar configuration, just changing the parameters. So on P2, we configure the VRFs, the virtual routing and forwarding instances, and commit. So if I display IP VPN instance, I expect that I have two VPN instances, VRF-A and VRF-B. Display IP VPN instance. Interface on this router, you can see that we have VRF-A with one interface and VRF-B with the other interface facing the other customer. So after this, the next step is to set up eBGP peering sessions between the PE. So we are using eBGP, the border gateway protocol, for the PEC routing protocol. So we need to set up eBGP peering session between the PEs and the CEs. So on the PE, we'll be configuring the BGP peering session within the VRFs. So you can see that we are specifying these as the VRF for the first session, and then these for the other peering under VRF-B. So this is a very straightforward configuration. So I'll go ahead and do the implementation. On P1, we need to configure, and then P2, we have C3 C2 and C4 actually. So we configure BGP peering session within the VPN instances. So on P2, I'll do the implementation and commit. So of course, if you check display BGP VPN v4 all peer, you expect that the sessions towards the CEs are down. Same on P1, I can do display BGP VPN v4. All peer. So you see that the sessions are still active because we haven't configured the CEs. So I'll go ahead and do the CE configuration. So this is the final step, and then we'll do the service test. So for the CEs, we need to configure the interface facing the PE, the provider edge router. We will configure a loopback IP that will be used to simulate a customer interface or customer device. And then we configure BGP. So when we are configuring BGP, we will advertise the loopback IP that we've configured. So on C1, you can see that we are advertising these 11.11.11.11. On C3, we'll do 33.33. On C4, 44.44. And then we'll verify that we can be able to receive these routes. We can communicate between the customers. So I'll start with C1. So on C1, and do a commit, I'll go ahead and do C2. So when you are copy and pasting these commands, you need to pay attention so that you do it on the correct device. And then we'll go ahead and do on C3. And finally C4. Then we can verify our BGP peering session and confirm the routing table. So starting with P1, if you run the command display BGP VPN v4 all peer, you can see that we now have BGP session towards C1 and C3. On P02, again display BGP VPN v4 all peering sessions. You see that our sessions are up, one in VRFA and another one in VRFB. So let's check our routing table. So first we check on the PEs. Are they receiving the route from the CE? So I do display IP routing table, VPN instance, VRFA. You see that we are able to get the routes from the customer end. Check VRFB. We are also getting 33.33. Remember, 33 and 33. C03 and C04 should be able to communicate because they are in VRFB. C1 and C2 should also be able to communicate. So on P01, we can also check display IP routing table, VPN instance, VRFA, display VRFB. You see that we are also getting the route, so we have the routing information propagated across the network, and you haven't seen me configuring any LDP, you haven't seen me configuring any RSVP. So everything else, the signaling is handled by the IGP that we've configured. Let me see whether I can see ISIS on this router, display ISIS. Know whether it will work. Let me see whether this, so we can do segment routing. Let's see the option that we have, because this is a simulation tool, so we may not have all the commands. So you see that this one we don't have any information, but again we've confirmed that we have the necessary routing information. On C1, if I display IP routing table, you will see that we have the routing information from C2. So are we able to ping? So if I ping -A, I'll do 11.11.11.11 and then 22.22.22.22. You see that we are able to ping from C1 to C2. Are we able to ping C3? You see that we cannot be able to ping C3 because it's in a separate VRF. So if we go to C3 and display IP routing table, then we can do a ping -A 33.33.33.33, and then we are pinging 44.44.44.44. You see that we are also able to ping the CE04, but we should not be able to ping the other CE in a separate VRF. So I'll do 11.11.11.11. We are not able to ping because those two are in a separate VRF instances. Again, on the PEs, you can display the BGP routing information, display BGP VPN v4 all routing. You see that we are getting the routes. They have been selected and installed in the routing table. On P2, display BGP VPN v4 all routing table. You will also see that we have the necessary routing information received from the peer end and installed in the routing table. So this is how simple it is to implement segment routing on Huawei routing devices. And you need to really pay attention and understand the working principles of segment routing, especially on how you activate segment routing on the router, how you configure the sRGB block, the segment routing global block, and also the prefix seed. So this is a basic implementation. You can do the traffic engineering one, which means that you will be having segment routing tunnels that are based on traffic engineering, the SRTE, that are based on segment routing protocol, and then you can have your network doing segment routing with traffic engineering. So I hope this is okay, and this has helped you to understand how to implement segment routing on Huawei routing devices. So again, we'll be having other sessions just highlighting the basic detail that you need to pay attention to, starting with the segment routing global block. How are they calculated? The labels, how are they calculated? How do we use the prefix seed index on these routers? How is it used to ensure that labels are correctly assigned on the routes that are received from different parts of the network? So those are details that we'll be discussing in our subsequent sessions, and I hope you stay tuned in for the upcoming sessions. So thank you so much for watching this episode, and just a kind request that if you are watching this session or if you've watched this session and you haven't subscribed to our channel, kindly support this channel by subscribing. Also remember to comment, remember to like, to share, and also to give us a shout out to your connections. So again, remember we had one issue that you need to tell us in the comment section. If I were to run this command again, just so that you get it right, should be the second command. So on P1, I'll run this command. Actually, it's the first command. So you can see that we have the labels, and I was asking why we have label number 3. What does it mean in MPLS? Why do we assign the label number 3? And what happens when you receive a label number 3? So please tell us in the comment section what the label number 3 means, even the null label. Why is it null? And why do we assign label number 3? What is the special thing about label number 3? So please do tell us in the comment section, and we will be following up to hear from you. Thank you so much, and see you in the next episode.